Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Arifah Nur Khalisha binti Khalid. My metric number is AE190057. This table shows the answer for our activity 1, the calculation and the simulation value. This is the manual calculation for activity 1. As for the simulation, we arrange the component like the figure given in the lab sheet. Then we put the load value, which the R1 and the L1. Then we get the current and voltage for the load value. Next, we repeat it using the different load value given. Record the value and put it in the table. So let's move on to activity 2, the parallel resistive inductive load circuits. As we can see from the table, this shows the calculation value and simulation value of our activity 2. Next, the manual calculation for activity 2. As for the simulation, it is kind of same as activity 1. We need to arrange the component like the figure given in the lab sheet. The difference is the arrangement of the component is parallel. Repeat it using the different load value given and record the data. That's all from me. Thank you. I'm sorry for the inconvenience because my camera has problem with the sound and the camera.
Hi, Assalamualaikum. My name is Farah Anis Nabila binti Shariful Bahri. My matrix number is CE190237. Okay, I will present about activity 3, series resistive capacitive load circuit. Okay, so now I will explain about the component that we use for these activities. For the power supply is AC supply. We set for 10 volt and 50 hertz. And for emitter, we need to change the display range. Choose milliampere. Okay. And so here we have 6 circuit, which difference value for resistor and capacitor. So now let's rerun. Okay. Okay. So the simulated value are same with the report. Okay. Right. Okay. For the first, we need to calculate the value for calculations, manual, and simulations. Okay, for XC, the formula is 1 over G omega C, and how to get the omega? Omega is 2 pi F, and F is 50 hertz. So we just insert the value and plus R to get the impedance value. For supply, we put 10 volts, such as the given. Okay. For current, we use the Ohm's law, VIR. So we need to find I over V equals Z. Okay, for voltage load, okay, um, are combinations from load from resistor and load from capacitor. So we get the value, and the value for currents is from AC voltmeter. Okay. Okay, so just put the value into the table. Okay, next we move to activity number 4 is parallel RC load circuit. Okay, we use the same diagram like activity number 3, but we just make it circuit in parallel. Okay, so we set up the value for V supply is 10 volt and 50 hertz. For both emitter is milliampere and voltage. Okay, so we run. Oh, by the way, we also just change the value for resistor and capacitor. So we run. Okay. Now we look at the report. Okay. For this, we need to find the value for Z. By using this formula, 1 over Z equal 1 over R plus J omega C. Omega is 2 pi F and F is 50 Hertz. Okay, so get the value by using this formula, and for Vs we use 10 volts, and the current is same. We use the formula from Ohm's law. The simulations value, we got the reload is 7.07. Okay, for all circuit, for all value for different RC, and the current is both plus RC and R and C current. This is the formula for this is the example formula for Z impedance. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul bin Ibrahim. My metric number is D1089. So I present for activity 5, the series RLC load circuit, and activity 6, the parallel RLC load circuit. And then first we need to simulate the series RLC load circuit. So I will use multisim. First we take out the AC power supply, ground. Next we need the impedance, is the first the resistor, and then the inductor. The last one is the capacitor. So we can rotate these three impedance, line it, and then we can connect this. Next we need to connect the indicator. We use an emitter, so emitter must be connected in series, while the voltmeter be connected in parallel. So in violet shade, we use 50 VHC and with 50 Hz frequency. So I will show, for example, we use 390 ohm, 0.4 Hz and 2 microfarad. So 0.4 and the capacitor is 2 micro. Then we can run the simulation. First we need to change the indicator to AC indicator. So you can see the result here is 0.028 ampere, or we can turn it to milli, so 28 milliampere. And here we have 50 volt with the and so it is 33 milliamp. In case we need to change the value, so for example we change the inductor value to 1.0 Henry. So you can see here 1 Henry. First stop the simulation and run it again. Then we can observe and record the value. Okay, let's move on to activity 6, which is the parallel RLC circuit. So it is the same, the emitter should be connected in series, while the voltmeter will be in parallel. So this is 390 ohm, 102 microfarad impedance. So let's run the simulation. So we have 181 milliamp and 50 volt for the voltage reading. So for example, we need to change the capacitor value to 8 microfarad. We start the simulation. So you can see the voltage value remain the same and the current value will decrease. That's all from me. Thank you.